Before we started at work yesterday, we decided to strategically divide ourselves into separate subgroups. These subgroups were used throughout the day. This allowed us to kind of better transfer some information and knowledge throughout all the multiple problems. My name is Jeff Bonica, and I worked on virtual construction and site logistics.
My name is Nick Swedberg, and I also worked on virtual modeling and site logistics.
My name is Jason Allred. I worked on estimating and also assisted Nick with modeling.
My name is Melissa Peebles. I work mainly on estimating while doing minor scheduling.
My name is Andrew Minifo. I work primarily on scheduling as well as with production control.
My name is Kyle Creasy. I help Jeff in the morning with the 3D modeling, and then for the rest of the day I help with scheduling and production control.
We began the morning by addressing the Revit model. We elected to use work sharing to allow multiple team members to work in the model simultaneously. Because of the nature of work sharing, we decided to partition work between our team members to minimize conflicts and increase our productivity. We had members work on, for example, floors, or other team members working on columns. We also had our modelers work in teams with our estimators. Our estimators helped read the drawings, but also helped naming conventions for the modeling process, so that way we would facilitate easier estimating later on in the afternoon.
As well, we worked on the schedule in the morning. It was a very basic question, so we took the time to really get to know the drawings. We got to know what the overall steel construction was going to look like and what the overall site layout would be. Once we had an idea of how the steel was going to be put together, we determined what 7 major tasks we felt would be necessary, and then we put them in an order that would work for every floor, pretty much like a recipe, so we could go through the building efficiently and quickly. From there, as a team, we decided that it would be most efficient to break the building up into 2 zones. We decided that 2 zones allowed for the most efficient site in the tight area we were getting.
Moving into the afternoon, we addressed the model QC portion of this problem. We chose to have our modelers from the morning work on the QC because of their familiarity with the Revit model. Because of their comfort with the model, having worked on it in the morning, our Revit modelers were able to quickly find several errors with the model given to us. We further searched the model by looking at 2D drawings for naming conventions and dimensioning issues, as well as visually assessing the 3D model to see if we could find further problems.
Some of the quality control issues that we captured are shown here. We had structural studs cutting through our cross bracing. We also captured missing stringers as well as overextended CMU walls.
Also in the afternoon session, we received the first estimating problem. We began by breaking this problem down into 3 sections: calculating the consumption factor, forming the quantity takeoff, and finally producing a cost estimate. We knew that calculating the consumption factor and the cost would be mainly number crunching, so we decided to focus most of our efforts on the quantity takeoff. To do this, we decided to use the model as it was in Revit, and as you can see, we separated each level into bays, and then we were able to select each structural component, and Revit then told us its type and volume. We then organized this data in an Excel spreadsheet and then factored in our consumption factor and waste factor. Then we looked at the cost and productivity data given to us, factored that in, and produced a final cost estimate.
Wrapping up our afternoon work, we used our zone breakdown from our morning scheduling problem and divided the building into 2 zones along the grid line F.6 to help us create a more effective and efficient schedule. With the foundation completely curing on May 10th, we utilized the quantification tool and Navisworks to figure out the time it would take to plumb and align the steel in the Tier 1, Zone 2 on the south end of the building, which consists of the basement and level 1. Then using the cost and productivity spreadsheet, we determined the average production rate with all the steel erection, the average of the production rates from the spreadsheet. Finally, by combining all of our data, we figured out that the steel erection will commence on May 19th.
As we progressed throughout the day, a lot of our deliverables were building up to constructability and ultimately a site logistics plan. As you can see here, some of the decisions that we made throughout the day, including much about scheduling, was reflected then into our site logistics plan. As Kyle mentioned, we decided to break up the building into 2 separate zones, and as a result, we felt that 2 cranes maximized our schedule as well. Our cranes were sized based off of our maximum pick, which was found to be about 110 feet away from our crane and needing about a 2.7 ton capacity. Our site plan also features 2 site access roads. The primary access road shown here on this side is accessible via south on Howard Street. The second access road is hidden behind the second crane, and that is via north on Minna Street. The site plan also features a pedestrian covered walkway and a site trailer located adjacent to the primary delivery zones for ease of communication.
Along with site logistics, later in the evening, we tackled our second estimate problem. This problem required us to find the total cost for bracing and decking tasks. Jason and I found that the most efficient way was to calculate these overarching items separately. So we started with bracing and found the two types, those are which architecturally visible and those which are simply structural. By doing so, we were able to take each of those items, plug it into our cost and productivity Excel sheet, and then derive costs. Similarly with decking, we went to each level, found the square footage and volume, and then again put it into the Excel sheet and derived costs. Revit was critical during this procedure because it allowed for us to easily select materials that we needed while also giving us numbers that were critical for the Excel sheet with a click of the mouse.
Finally, in the evening, we decided that the most effective way to handle all the scheduling questions was to first have a final overall schedule of the build. We used Microsoft Project and Logic Connections to determine what would be the most effective order of the building, as well as what buffers and different connections we would need to make sure not only the building was safe, but it was also being produced at an efficient rate. With this in mind, we knew that production control was also a factor, and we had to be prepared for any changes that could be coming. With this overall schedule, we took the date and restraints on resources that we were given and plugged it into our schedule to see what effects it would have. From these effects, we determined solutions that we felt would be most effective to address each of these. For instance, we determined that possible solutions for the lack of ability of concrete would be possibly importing concrete from other regions or increasing the crews later on in the trade.
I'd like to thank you guys for the opportunity to participate and help answer any questions you may have. Thank you.
Started off by, what did you find the most challenging?
It kind of differed. I'll have everyone kind of take their own piece. For me, the most difficult piece was actually the ground up modeling and just getting into documents for a project that you've never seen before.
Working primarily with modeling, I would have to agree with Jeff. For the most difficult part for me was just getting familiar with the building and trying to quickly put that into a model accurately, and still being familiar with all the drawings we were looking at.
For me, it was the first estimating question because of the wide scope of things we had to take off from the model. Just a lot to get done in that time period.
And I would agree with Jason. Some of the terms are unfamiliar and things like that, so we kind of struggled there. But
For us, it was the third section of scheduling, because it really required a full schedule to understand necessarily what was going to change and how it was going to change throughout the building. And working with all the estimates and stuff like that was difficult to get all the information together accurately.
I like the idea of giving us an extra hour on the second part of the state of the problem, but when we only had 4 hours left to do the third problem, we were reading through it. It was just like every piece just kept building on each other. It was just like it's never ending. But I guess overall, it wasn't that bad, but I mean, that was the most challenging part for me personally.
Here we laid out site logistics. So how did that help you? Did it hinder you? Well, kind of site logistics, because we had a lot of scheduling questions. So you learn to visualize and understand what was going on.
Absolutely. I think we worked with our schedules throughout the site logistics piece of it. We had both parties, even though we had kind of those subgroups we showed you, work together throughout the day. So every time a decision was made in scheduling for how to break something apart and estimating, that decision carried over throughout the day. And that's why we tried to kind of weave our people around into different groups throughout the day. But I think it was challenging, but it was good to kind of, I liked having that logistics piece at the end to kind of help put it all together and say, okay, here's, we estimated it, scheduled it, now let's see exactly how we're going to put it together.
Why did you use SketchUp versus Revit?
One of the things about SketchUp that we liked is we were able to put the existing building in there as well, geolocate and help kind of get us a general kind of idea about the site and its surroundings as well. You really can't get an appreciation for how tight a site is until you looked at it in 3 dimensions and realize, hey, we really can't put that there, and we don't have as much space as we thought we did. In Revit, you kind of can get lost inside of it as far as your surroundings go.
Well, I guess I'll ask the stumper, or some people and stuff. We gave you a database in master format code. I guess typically when we use Visual Office and the way we organize it, we'll roll up into uniformat and then use master format at a certain level. Do you know why you would do that? Or do you know the differences between the two codes? What gives one advantage over the other?
With my experience with master format and unit format, whereas I'm not necessarily sure how they work together, I do understand that when we were using unit format throughout the day or even throughout school, unit format has more of a natural flow to it, allows you to see necessarily, it groups things better in my opinion, it's easier to understand, whereas master format has a lot more information. So kind of, for me, it almost filters things through. That's normally how I would use it, but outside of that, I do not really know.
Yeah, you're along the, it's system-based format, right? So you can roll all steel into one code structure, and then when you get to the task level, or trade level, that's when you start using master formats.
You see portion of this problem, there's a lot of elements in that model. How do you go about filtering through and seeing where the issues were?
We started by using the people who have been modeling in the morning, and the way we addressed it is because of their familiarity with how they've been modeling, we went and checked the things that we had modeled in the morning. So whereas Jeff had worked with the columns, he immediately went and started to look at those elements because he was familiar, having looked at the drawings, their sizes and their names. I started to look at the floors because I had spent most of the morning working on the floors. And then after that, we addressed it by just looking at the drawings for issues we thought might arise, like naming conventions or dimensioning, things that we thought would be easy slip-ups that could happen in real life in a model. And then we also just, sometimes it's just best to look at it, so we just observe the 3D model, rotate it around and move through it, because sometimes you just catch things that way, and we actually did catch a couple errors looking at it that way as well.
So the premise of the problem was how we tied into the estimating portion as well as the scheduling and then field use as well. How did you guys work as a team to make sure that the data flows between all of those aspects?
As a team, like we mentioned on our second slide, we kind of intermixed ourselves so that the information, not only were we sharing our people across the different 3 types of problems, we were also sharing the information. So as Nick mentioned, I also worked on the modeling for the columns and the QC for the columns. And then when it came time to schedule, I was also the person that was responsible for supplying that information so that those quantification numbers could be provided to those guys who were building that master schedule. It was just a very coordinated handoff process throughout the day.
You guys mentioned consumption factor. We gave you a question on the consumption factor for steel. How did you build out something?
First, we started by researching the A902 steel, the product that you gave us. We found the density for that, and then we figured we'd take the volume out of Revit, find a weight for all the figures, and then that's how the cost data that you gave us was presented, and weight and price, and got the cost out of that.
Great. Good job, guys. Thank you.
Thank you.